Okay, in the last video, we were attempting to solve this integral of 1 minus the cosine of 3t to the 3/2 power. And we kind of fished around, frankly, with some trig identities to see if we could get this into a form here that we could integrate. And what we ended up with is 1 minus the cosine of t equals 2 times the sine squared of t over 2. So we're going to put that into here. And we need some room. Let's go down to here. So we have a equals 2 times the square root of 2 times a squared pi. And we're going to take the integral from 0 to pi, not of 1 minus the cosine of t, but of this. And this is going to be raised to the 3/2 power. So that's going to be 2 to the 3/2 power times the sine squared of t over 2 to the 3/2 power dt. So that becomes our new integral, and 2 to the 3/2, that's 2 times the square root of 2. So we take that to the outside. We already have a 2 times the square root of 2 sitting out here. So this is going to be 2 times the square root of 2 squared, and then this goes away. And the sine squared to the 3/2 power, it's just going to be this cubed. So let's just rewrite it and try and write it a little bit neater. Sine of t over 2 cubed. So we have the sine cubed of t over 2 dt. And what is this going to equal? So here we have 2 squared, that's 4. 2 over 2 squared, that's 2, so this should be 8. A squared pi times the integral of the sine cubed of t over 2. That's the same thing as the sine squared of t over 2 times the sine of t over 2. And the sine squared of t over 2 we can write like this. 1 minus cosine squared of t over 2. That's the sine squared times the sine of t over 2 dt. And t goes from 0 to pi. That then we can integrate finally. So let's make some room to do that. It took us a while to get there. And sometimes when you're dealing with these parametric equations, that's what you end up with. It's not terribly difficult, but there's a lot of steps that we have to deal with. And also, we're trying to take it slow and go step by step so we don't make any mistakes along the way. Let's see. We have, I'm going to write it up here. Area equals 8 pi a squared integral from 0 to pi 1 minus cosine squared of t over 2 times the sine of t over 2 dt. And in just a second, you'll be able to see that. Okay, there's our integral. Now, we look at this, and here's why this is so neat. If we say, well, let's call cosine of t over t, let's call that u. There's minus du right there looking at us. So we'll go like this. Let u equal cosine of t over 2. Then du will equal, that's minus the sine of t over 2 times 1/2, because it's the derivative of what's inside, dt. But we don't have minus 1/2 the sine of t over 2 dt. We just have this, so multiply both sides of the equation by minus 2. We have minus 2 du will equal this. So now, our integral will look like this. 8 pi times a squared, and this will be 1 minus u squared, and this, that's minus 2 times du. So we have du and minus 2 out here. Minus 2 times 8 is minus 16. And I'm just going to remind ourselves we're going t equals 0 to t equals pi. And then we'll take care of that in just a second. Our t limits, that is. Let's see, have we made any mistakes? It looks like we should be pretty much on target with this. So, let's see. This should be equal to minus 16 pi a squared, and this would be du, that would be u, minus u squared, that integral would be 1/3, u cubed. And we have to remember now, this is what u is. So we're going to get the area equals minus 16 pi a squared times this, cosine of t over 2 minus 1/3 the cosine of t over 2 cubed. And t goes from 0 to pi. Okay, we should be all set. If we go ahead now, a will equal minus 16 pi a squared times t is now pi, so the cosine of pi over 2 minus 1/3 cosine cubed pi over 2. I'm going to write this so big. Minus, now we put when t equals 0, and we're going to have cosine of 0 minus 1/3 the cosine of 0 cubed. And the cosine of pi over 2, that's 0, this is 0. Multiply those together, that's going to be a equals plus 16 pi a squared. And the cosine of 0, that's 1. And then that's 1. 1 cubed is 1. 1 minus 1/3, that's 2/3. So this would be this times 2/3. That would be 32 over 3. And that would be our area. So that's it. Sorry if it was a little bit lengthy, but again, that can be typical when we're dealing with parametric equations. We want to try to pick a representative sample so that if you do encounter some of these, hopefully you'll be better prepared for them. Okay, come back, join us for some more videos, and we'll try and solve some more problems.